Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the gyroscopic sensor. What is the use of gyroscopic sensor in the wearable device and what are the applications it is used for? Gyroscopic sensor. Gyroscopic sensor or a gyro sensor is a device that measures or senses angular velocity. Okay. Gyroscopic sensor or a gyro sensor. It is named as a gyroscopic sensor or as a gyro sensor. It is a device that measures or senses angular velocity. In simpler term, it detects rotation and change in orientation. Okay, this gyroscopic sensor which is used to measure the angular velocity. In simple terms, we can tell that it detects rotation and change in the orientation of an object. Okay. It's designed to measure how fast an object is rotating around a particular axis. Okay, often referred to as an angular rate. This is particularly designed to measure how fast the object is rotated around a particular axis. If it is present in an x-axis, how fast it rotates in the x-axis, that can be measured. If it is present in the y-axis, it can be it is used to measure how fast it rotates in the y-axis. But likewise, it is particularly designed to measure in which axis how fast the object rotates around a particular axis. Okay, based on the principle of angular momentum, where a rotation object tends to maintain its orientation in space. Okay, based on the principle of angular momentum, where a rotating object tends to maintain its orientation in space, it is designed to measure how fast the object is rotated around a particular axis. Okay, a gyroscopic sensor or a gyro sensor, it is a device that measures or senses angular velocity. In simple terms, it detects rotation and changes in orientation. Okay, it is also called as angular rate. This angular rate is determined by how fast it rotates around an axis in a particular axis. Okay. Next, how does it measures? Okay, measuring rotation, Coriolis forces, single conversion, and output. Finally, we'll go for output. How it can be measured and what are the processes used for measuring? Measuring rotation, Coriolis force, signal conversion, and output. What is called measuring rotation? Most modern gyroscopes, especially those who used in consumer electronics, are categorized as micro electromechanical system gyroscopes. Okay, this is called measuring rotation. The most modern gyroscopes, especially those used in consumer electronics, are categorized as micro electromechanical system gyroscopes. Coriolis force. These sensor functions based on the Coriolis effects. Coriolis effects, a tiny vibrating element, which is a very tiny vibrating element usually made of quartz crystal. This is a force, okay, which is used in a vibrating element made up of a quartz crystal. It is set into a motion. This element is set into a motion. When the sensor rotates, this Coriolis force affects this vibrating element, causes a subtle perpendicular vibration. Okay, once this force affects the vibrating element, which the element is vibrating in a quartz crystal, that will be moving in a perpendicular vibration. Okay, signal conversion, how the conversion is done. This secondary vibration is then converted into an electrical signal which corresponds to the angular velocity. This perpendicular vibration we get is that signal is converted into an electrical signal. okay, which corresponds to the angular velocity. Next, finally, what the output will be of the sensor output, then this outputs this electrical signal, which then can be processed by the microcontrollers to determine the rate and direction of the rotation. Okay, the electrical signal which is produced by the signal conversion process, when the angular velocity is converted into the electrical signal, vibration is converted into electrical signal, that can be sent into the microcontrollers to determine the rate and direction of the rotations. This is the process of gyroscopic sensor. Thank you.